Hello, folks. So today what we're going to do is we're going to talk about a well-designed experiment. So looking at the pictures that we have here, you can kind of make a conclusion about what it is that we will be talking about. There's a little bit about Mentos here, a little about paper airplanes, and something about The Simpsons. So first thing that I want you guys to do is I know whenever I go on YouTube, I always find these really cool videos about science experiments. And here is one that I found, and I want you to think about, is this a science experiment?
This is really good. All right, so here's the setup. Mentos, and the reason we choose Mentos is because they have this chalky-like quality to them.
Right.
What we want is
That's
we want,
a coating
yep,
on the outside.
and we're just going to put them into the test tube, so they go down into the test tube like this. So there's your test tube. Got it?
Okay.
13 Mentos, just in case you're counting. All right, so
Oh,
there
good.
it is.
Some people
All right,
probably are.
so now let me open this up here, and yours, you can open yours up as well. All right.
Okay.
So,
Losing
and we're
Mentos.
just using diet just because it's less sticky when it finally there's a disaster.
Oh, when there is a good one.
All right,
Okay.
so now here's what's going to happen. We put the card on, we turn the whole thing upside down. We're going to put it over the top. We're going to
Okay.
position it so it's right over the top. You got it? So right there on the
Okay.
edge.
All right.
Now, when we pull it out, those are going to fall real fast. And when they do, all of the bubbles that are inside are going to rush to them, and we might see a little eruption. Are you ready?
Yay!
All right, so
Let's
we're
go.
going to go 3, 2, 1, pull. Ready?
Okay.
3, 2, 1, pull. Good. Ah!
Woo!
Is that? Tell me that that's not
Okay, I did
awesome.
get
Is that?
it. That's
okay, no,
awesome.
I'm so sorry.
That's
Look,
okay.
look at you. You are.
It tastes kind of good.
It wasn't that fun?
Yeah, it was fun.
That's the best I have ever seen, isn't it?
I had to stand in between
I know,
all of
I
you,
know.
that's
But
why.
it was,
All right. So if you're filling out a worksheet, you might find at the top of your worksheet, the question is the Mentos fountain a science experiment? If you're writing in your journal, I want you to take a second, pause the video, and reflect. Is this a scientific experiment and why? All right, so we're going to be coming back to this a little bit later. But for now, I want you to take a second and you're going to write this down, whether that be on your worksheet or in your science journal. If you need to pause the video, pause the video. So the first thing is an investigative question. All experiments have an investigative question of something that you're trying to find out, something that you can test and see. Like, does the size of the hill matter whenever affect how fast a car is going at the bottom of the hill? Does the amount of baking soda affect how big the reaction is with vinegar? So you try and see how one thing affects another, which is why we have the frame here. Does blank affect blank? So most scientific experiments have an investigative question of some sort. We also have hypothesis. I think blank will happen when I blank because I think the car will go further when I increase the size of the hill because it is picking up more speed on the hill. So using that frame will help you come up with a hypothesis. There are also parts of an experiment, which are variables. And so variables we'll get into here in a little bit. And then you also have a control, something that you can compare to. So I'm going to use this paper airplane test as an example. So for an investigative question, it must be something I can actually try and find an answer to. So for example, if I had two paper airplanes, I could do a test of, does the length of a plane affect how far it flies? So if I were trying to test, can a paper airplane fly? I'm not really testing something about it, trying something with it, trying something without. So I have to have something I can test. So for this particular experiment, does the length of plane affect how far it flies? So I'm going to have two paper airplanes. exactly the same type of fold. It's just that I made one out of one size of paper and I made the other out of another size of paper. And it's the exact same paper. So then I would go and I'd make a hypothesis of what I think would happen. So think about it. What do you think might happen in this experiment? I think that when I have a paper airplane that is shorter, the plane will not go as far because the wings do not catch as much air. Or I could make my hypothesis. I think that when I make a plane shorter, the plane will fly further because it does not have as much weight. So I said that both ways. I could do either way. There's no right or wrong on a hypothesis. It's what you honestly think is going to happen in an experiment and why you think it's going to happen that way. All right, so the next part, I'm going to have you pause the video and write this down, whether that be on a worksheet or in your science notebook. So a variable is a part of an experiment. Every experiment has multiple variables. So every little piece about it. So if I'm talking about my paper airplane experiment, I have the type of paper, I have the fold of the paper airplane, I have the size of the paper airplane, I have the wind speed of the room, I have how I throw it, where I throw it from. All of these are little pieces of the experiment. So the idea with an experiment is you're trying to be as fair as possible as you're testing it. So in your experiment, you are only supposed to be changing one little tiny thing. Absolutely everything else is supposed to be exactly the same. So your independent variable is the one little thing you change. Your dependent variable is because you make your one little change, what do you expect to be different? So if I change the size of the height of the hill on my car track, that would be my independent variable. And what I think that's going to affect is the dependent variable, the speed that the car is going at the bottom of the hill. So we have independent variable is your change. Dependent variable depends on what happens with the independent variable. So what the outcome's going to be. Then we have constants or controlled variables. So constant variables are the things that are kept the same, constantly the same. So a constant is never going to be changed. If I'm talking about my tracks with the car and the hill, I would not change my track. I would not change my car. I would not change the surface that the car is on. I would keep absolutely everything the same in my experiment, only change the height of the hill. So we have constants. We have independent variables and we have dependent variables in any scientific experiment. So let's think about this. I have an independent variable in my plane. Did I only change one thing? What did I change? If you have a science notebook, you could write that in there. If you have a worksheet, it might ask you that question. So, did I change only one thing? Yes. I only changed the length of the plane. That is my independent variable. Every single thing should be the same whenever I go to test the plane. I should be flying it the same way, throwing it the same way, have the same wind effect of the room. So if I take this outside, it might be kind of hard to make sure that the wind's always going to be the same. I would need to use the same type of paper. I can't make one out of like heavy cardstock and one out of regular paper. I couldn't make one out of tinfoil and one out of regular paper. That wouldn't be fair because the thing I am testing is the length. Then I have a dependent variable. what do I expect to be different because I changed the side of the plane? So what is it that I'm measuring and taking data on? In this instance, I'm taking data on how far the plane is able to fly. So as long as I'm keeping the other variables the same, I should be able to see if the length of the plane makes it fly a different amount. Then my constants are the things I keep the same. I have to be fair in how I'm testing. Everything has to be the exact same way every single time. Otherwise, it's not going to be an accurate experiment. So if I were to change, for instance, the length of the plane and the type of the paper, how do I know if the plane length made the distance change or the type of paper? If I do only one thing at a time, I can figure that out. But if I try and do too many things at once, I have no idea what's making the change. So constant or controlled variables are always the same. So we're going to look at an experiment and see if you can figure out what the independent, the dependent variables are in the experiment. So here's the first one. Smithers thinks that a special juice will increase the productivity of his workers. He creates 2 groups of 50 workers each and assigns each group the same task. In this case, they're supposed to staple and stack a set of papers. Group A is given a special juice to drink while they work. Group B is not given the special juice. After an hour, Smithers counts how many stacks of paper each group has made. Group A, the experimental group, made 1,587 stacks. Group B, the control group, made 2,113 stacks. So I want you to pause the video and think about this. What is the independent variable and what is the dependent variable? And if you have a worksheet, you might need to write that down. Or if you have a science notebook, you might need to write it down there. So pause the video and think about it. All right, so in an experiment, we have all kinds of constants. So everything about the workers and the work environment and the juice and everything needs to be kept the same, except for the one thing we're changing. So what is the one thing that's going to be different between the 2 groups of people? And that would be the juice. So one group got the juice, the other group did not get the juice. So that is the independent variable. The dependent variable is what we expect to be different because they had the juice. So what do we expect them to do differently? Well, we expect them to be able to get more work done. Or if the juice doesn't work, maybe less. So that is our dependent variable, how much work gets done. And in this case, they were making stacks of papers. So Smithers would be able to figure out if the juice was effective. Let's look at another example. Bart believes that mice exposed to microwaves will become extra strong. Maybe he's been reading too much Radioactive Man. He decides to perform this experiment by placing 10 mice next to a microwave for 10 minutes. He compared these 10 mice to another 10 mice that had not been exposed. His test consisted of a heavy block of wood that blocks the mouse food. He found that 8 of the 10 microwave-exposed mice were able to push the block away. 7 out of 10 of the non-microwave-exposed mice were able to do the same. So pause the video, take a second, and think about what is the independent variable, the one thing that was changed in the experiment, and what the dependent variable was, what you expected to be different because you changed something. Okay, so overall, remember, everything has to be constant. You have to have everything the same, except for the one thing that you're changing between the 2 groups. So between the 2 groups, the difference is the microwaves. So sitting next to the microwave for 10 minutes is the independent variable. Every single thing about the mice has to be exactly the same in order for it to be an accurate experiment. Then, what do we expect to be different because the mice had sat next to the microwave? Well, the strength of the mice, right? Whether or not they were able to push the block out of the way. So that's your dependent variable. So the ability of the mice to push the block away is dependent on whether or not the microwaves had an effect. So independent was the microwaves, dependent was the strength of the mice. All right, so pause your video and I'd like you to please write these down, both the dark part and the color part. All right, so in a good experiment, you have to make sure that you're doing these things. Otherwise, it is not a quality scientific experiment. You have to, and the way I remember this is mad scientists, very creative robots, so that I know in a good experiment, I must have these things. I must have multiple trials. I must have a decent sample size. I should have my variables taken care of, so I'm sure I'm only changing one. I should have something to compare to in the experiment, and it should be reproducible. It should be able to be done again. So let's first talk about multiple trials. A trial kind of sounds like the word try. So each time that you try an experiment, that is a trial. So is it okay for me to take and fly my plane once and make my conclusion from that? What do you think? I think it would be very difficult because let's say for some reason something goes funky in my experiment. Like, for instance, maybe a gust of wind comes in. Maybe I didn't by chance throw the paper airplane the exact same way this time. So, whenever you have an experiment, it needs to be tried multiple times in order to make sure it is an accurate conclusion. Generally, in science experiments that you find at school, you end up doing an experiment about 3 times. However, if you do an experiment more times, you are going to have a more accurate result. So this is the one that goes with MAD in my mnemonic device in order to remember. So multiple trials. You also have to have a sample size. How many times do you need to do something to show it works? Is it better to have more? So generally, more data is better because you have more times that you've tried something to get something to work. So yes, you need more times. Sometimes, whenever you're doing an experiment, it's good to have more than one person do the experiment and then compare the results to see if they're accurate. Because maybe the person was doing something that was a little off from what another person was doing. So you should always have a good sample size. This is the scientist version of my mnemonic device. You should also make sure that you have only changed one variable. Think about why that might be important. It's important that you only change one variable in order to make sure that the experiment is fair. So if I'm not paying attention to making sure everything is the same every single time except for the one thing I change, how do I know that that one change had an effect? If I'm changing a whole bunch of things at once. So one variable is important. Then you have to have a control. How do I know if anything is different when I change something? So you notice that I have 2 paper airplanes that I test. So how do I know what a regular paper airplane does? What I would expect an airplane to do? Well, I have to test one. So I have my larger paper airplane, which is a normal paper airplane. I'm calling that my normal one. Then I have my shorter paper airplane I am going to compare to the longer one. That way, I know by changing wings, the length of the wings or the length of the paper airplane is going to have an effect or had an effect by comparing the data from both of them. So you have to have a control, something to compare to in the experiment. And the experiment has to be reproducible. Can we do the experiment again and get the exact same way and the same results? So, would I be able to hand this experiment off to a person and tell them how to do it? And they would be able to do it the exact same way I did it and find out the exact same thing I got. So, that's reproducible. So, reproduce, you might think of making a copy of. That's what this is. Making sure other people can do the same experiment over again in the exact same way. Otherwise, you have people that are going to be comparing results and it isn't accurate. So you have to account for every little piece. So I want you to go back to looking at this video. And I want you to think about, is this actually a scientific experiment?
This is really good. All right, so here's the setup. Mentos, and the reason we choose Mentos is because they have this chalky-like quality to them.
Right.
What we want is
That's
we want,
like coating on
yep,
the outside.
and we're just going to put them into the test tube, so they go down in the test tube like this. So there's your test tube. Got it?
Okay.
13 Mentos, just in case you're counting. All right, so
Oh,
there
good.
it is.
Some people
All right,
probably are.
so now let me open this up here, and yours, you can open yours up as well. All right.
Okay.
So,
Losing
and we're
Mentos.
just using diet just because it's less sticky when it finally there's a disaster.
Oh, when there is a good one.
All right,
Okay.
so now here's what's going to happen. We put the card on, we turn the whole thing upside down. We're going to put it over the top. We're going to position it so it's right over the top. You got it? So right there on the
Okay.
edge.
All right.
Now, when we pull it out, those are going to fall real fast. And when they do, all of the bubbles that are inside are going to rush to them, and we might see a little eruption. Are you ready?
Yay!
All right, so
Let's
we're
go.
going to go 3, 2, 1, pull. Ready?
Okay.
3, 2, 1, pull. Good. Ah!
Woo!
Is that? Tell me that that's not
Okay, I did
awesome. Is
get
that?
it. That's
okay, no,
awesome.
I'm so sorry.
That's
Look,
okay.
look at you. You are.
Oh, it tastes kind of good.
It wasn't that fun?
Yeah, it was fun.
That's the best I have ever seen, isn't it?
I had to stand up and
I
drink
know,
all
I
in.
know,
That's
but
why.
it was
All right, so if you're working on a worksheet, I'd like you to write down, answer the question, is that a scientific experiment? If you have your journal, I want you to write down in your journal, is it a scientific experiment? You can go ahead and pause the video while you do that. All right, so what I would expect you to be able to do is I would expect you to be able to talk with your teacher and find out, is this a scientific experiment? See if you are right. A lot of videos on YouTube are going to be labeled scientific experiment, but not all of them are going to be scientific experiments. This particular experiment has a lot of problems with it. So whenever you watch YouTube videos, take a second, think about it, whether or not you were actually watching an experiment.